Hey everyone, and welcome to a new video. It's Federico here. First of all, some pretty big news. My baby boy is born last month in January 2024. I am a super happy and proud father, and I just wanted to share this with you. Also, during the video you may hear some sounds from my baby because he's hanging on me on his carry-on. He's making some pretty cute noise that could go through the mic, so if you hear some strange sounds, that's where it comes from. And cool, so in this 8th video of our Jitter course, we are going to talk about 2D mode and layers, so how to transform the world from a 3D world into this 2D world where there is no depth, right? And we can choose which object is on top of which other using this layer system. This is very simple, nothing complicated, so should be a pretty short video, and without any further ado, let's jump into it. Have fun! So let's start from an empty patch and let's create our Jitter world object. Let's give it a name and let's call it 2D underscore world or something. And at the moment it's not 2D. Let's give it the attribute full scale anti-aliasing as we've seen in the previous videos. Then let's give it floating 1 so the window will not disappear behind our patch. And then let's give it enable 1 so it's going to be enabled by default. And that's basically it. So now, as you can see, the window will not disappear behind our patch. So at this moment, this world is still not 2D. We are still in our good old 3D world. In fact, if I'm going to create a GGL grid shape and attach it explicitly to our world, we will have our shape in our virtual environment. And if I create a GGL camera, touch it again to 2D world, and then create a JIT anim drive as we did in the previous video with the attribute UI listen 1, so it's going to listen to my keyboard input. You can see that I'm still in a 3D environment because I can move around the object in 3D. If I go and attach a GGL material to the GGL grid shape, we will even have some light interaction. And you can see that this is definitely a 3D world. So let's create a little scene. Let's create a bunch of grid shapes. I'm going to make this a cube, and I'm going to place it with the position attribute on the left of our sphere. So -2, 0, 0. That is our cube. As you can see, the GGL material interacts differently on the cube than on the sphere because of the geometry of the cube. Then let's create another shape and let's make this a torus. And let's place it on +2. So on the right of the sphere. Let's make this a bit brighter actually. So let's put this at -4 and this at 4. Right. And if I want to reset the position of my camera, if I get lost here in the virtual space, I can just send the message anim reset both to the JIT anim drive and to the camera. So not only to the JIT anim drive, but both to the anim drive and the camera. And that works. Let's actually give the tripod attribute to the camera as we did in the previous video. So the camera will not tilt, and it's pretty nice. And let's also maybe change the background color of our JIT world. So I'm going here, just right-clicking here on the input with the patch unlocked, choosing the erase color attribute, and then I can nicely change the background to a color that I like something like that. And let's also assign a color to our shape so it looks a bit more lively. So I'm going to go here in the shape and set color. This is going to be red, for example. This one is going to be green, good old RGB. So 0, 1, 0, 1 for green. And that's going to be blue. So color 0, 0, 1, 1. Right. All right, so now it's time to go from our 3D world to a 2D world. So a 2D world is a world in which the Z component of the position, the objects doesn't matter. And also we don't have any perspective on our virtual world, on the visuals. Okay, and we're going to achieve this by using an orthogonal projection instead of a perspective projection. So an orthogonal projection will get the area that the camera is looking at, which is called the frustum, and we squash it into a rectangular frustum. Okay, so everything that was before looking smaller because it was farther away will now look exactly the same as objects that are closer to the camera. So this is how we can transform our 3D visuals into 2D visuals. And in order to do that, we need to go on our camera and set the attribute ortho to 2. So by default, ortho is set to 0. And if we set it to 2, it means we are now using orthogonal projection instead of perspective projection. So if we go here and grab this attribute with an A3 object, we can then go here. 0 will be our perspective projection, the default one. Ortho 1 means orthographic, but also we can use the lens angle. So if we want to widen our field of view, we can go here and choose lens angle and make it wider, so we see a bigger portion of the scene. And if we go 2, the lens angle doesn't have any effect anymore. So let's actually choose the first ortho projection, so with the lens angle that has an effect on the field of view. So let's go here and let's reset ortho 1 and then set lens angle to something like 135. So we can hard code that. And now we can still move with the camera around, but it doesn't really have any effect. The only effect will be that at a certain point the near clip plane, which is the closest plane of the view frustum to the camera, will start to cut out the objects, which is also kind of cool. So you can keep this as an effect if you like. What I'm going to do is just to set anim reset and just get rid of the JIT anim drive, right? We don't need it anymore because we cannot move around our world anymore. Now this is a 2D world. So let's get to the second part of this tutorial now and talk about layers, because let's check something. What happens if I get this GGL grid shape and change its position attribute, here with another inspector, and place it like on top of the torus, just like that. And I would actually like that the torus is in front of the sphere. So what I can do is to get also the position of the torus and change the z value, for example, so that it can be placed before the sphere. But as you can see, if I go a bit too much with the z value, the torus will be clipped away by the near clip plane, as we said before. So there is another way to do that, which is to use layers. So every 3D object has also a layer attribute, which defines which one of these objects gets drawn first. So let's give it a try, and let's say that I want to have the torus to be rendered before the sphere. So I should set it to a lower layer than the sphere, and by default the layer is 0. So a lower layer than 0 is going to be a negative number. For example, -1. But as we can see, this is not working yet. And that's because we need also to set another attribute, which is depth enable. So let's set it to 0, depth enable 0. So depth enable 0, so this means that the render engines that powers Max will not check anymore for the Z position of those objects in order to set which one is on top of each other, but will only use the layer. So now if we want to have the torus appear on top, and sorry, I mixed it up. If we want to have a shape on top of another, the layer must be higher than the other shape, right? So if we want a shape to be on top of another, its layer must be higher than the other shape. Okay, so for example, if we have layer 0 here for the sphere and layer 1 for the torus, then the sphere is going to be behind the torus. Otherwise, if it would have a layer 2 for the sphere and layer 1 for the torus, then we will have that the sphere will be on top of the torus. So if we have the same layer, then it's kind of random, let's say. But let's set this depth enable attribute for each one of those objects. So let's go also on the cube and set depth enable to 0. This is important to get this layer system working. So let's actually set them all at the center. So going to set them all at the center of the screen of our rendering window. Right? And then we're going to play around with the layers to see which one is going to appear first. And maybe I reduce a bit the lens angle here. Nice. So let's change, for example, the layer of the cube to make it appear on top of everything. And we can just set it to something like 2. Or if we want the torus to be on top of everything, we can set the torus to be with the highest layer. And so on. Okay, this is how this works. And one thing to note is that we also have the ortho attribute on our JIT world. So if we don't have a camera in our scene, we can choose to set the ortho attribute also on the JIT world, right? But if we have a camera in the scene, the camera is always going to override the ortho attribute of the JIT world. So even if we will set this here to perspective, the camera is going to override the attribute on the JIT world. So it's just good to know. So once we are in 2D mode, it's important to remember to not necessarily use the Z position anymore, but use this layer system with the depth enable set to 0 in order to choose which objects appear on top of which other. 2D visuals are amazing. We could have like little 2D games or 2D particle system stuff that we're going to see in future videos. But for the moment, it's good to know about this layer system because this is important for as an introduction to our next video, which will be about blending. And for blending, we need to know about this layer stuff. Okay, so thank you very much for following. As you can probably imagine, I am pretty busy those days with the baby and everything, having kind of a heavy lack of sleep. But it's all very much fun. Just to say that I will try to keep those videos coming, but if it's going to take some time between a video and the other, please bear with me. Thank you very much. In the meantime, you can download this patch and tons of other patches that I made in the past from my Patreon. Link I will leave in the description. You can also access my Discord channel where I'm still pretty much active every day. So thanks a lot for following, and I will see you in the next video. Take care and see you soon. Ciao.